Hey guys, and welcome to this video. In this video, we're going to talk about sample space diagram, the rest of probability questions. Here, we're talking about sample space table or sample space diagram and how to use it to solve questions regarding probabilities. The question here says a black die and a white die are thrown together and the scores are added. Copy and complete the sample space table showing all 36 possible outcomes. Use your table to calculate the probability of these. So first thing we do, we have to complete the table, and completing the table by adding the scores together. Focus on the questions, make sure that you read the full question before you start answering the questions. So first, we understand that we have to add the scores. Scores are added. Sometimes questions come in a different way. They might ask you to multiply the scores. They might ask you to subtract the scores. So focus on the question. Read the whole question and then start answering the question. Because most problems come from you answering a question without reading the full question because you don't know what's wanted from you, and you guess that it's adding or multiplying. You just do whatever you want to do. Now let's first finish the question by adding the numbers. These are done for us, so this is 2, 3, 4, and then 5. We have to make it small so we can fit it in. So here 5, and then 6, and then we have 7 here. 2 plus 3 is going to be 5. 2 plus 4 is going to be 6. 2 plus 5 is going to be 7. And 2 plus 6 is going to be 8. 5, 6, 7, 8. Same. So 5, and then 6, and then 7, and then 8, and then 9. Here, 4 plus 1 is going to be 5, and then 6, and then 7. 4 plus 4, 8. 4 plus 5, 9. 4 plus 6, 10. And then here, 5 plus 1 is a 6, and then 7, 8, 9, 10, and 11. Okay, first, yes, okay, and 11. Okay, now the rest here, we have 6 plus 1 is 7, then 8, then 9, 10, 11, 12. Now we finished the whole table. Now we're going to use it to answer these questions. Find the probability of getting a total of 6. Now we know that all the possible outcomes are 36. This means the denominator in these answers will be 36. So a total of 6. How many sixes do we have? Let's count them together and put a line so we know that we counted it. 1, 2, 3, 4, 5. We can get 5 sixes out of 36. So when we write it 5 over 36. So 5 over 36 like this. So focus on this. The total outcomes are 36, and the totals of 6 are 5. We don't count these because these ones are in the dice. Don't count them. We count the outcomes only. So we have 1, 2, 3, 4, 5. So 5 over 36. A total more than 10. A total more than 10. So let's do the same thing here. Let's count them. A total more than 10. So we have 11, 12, and 11. They didn't say at least 10. They said more than 10. This means that you don't count the tens. You don't count the tens. So they are 3. The total more than 10 are 3. And the total is 36. So 3 out of 36, like this. Now you can leave it like this or simplify it. It's up to you. As, except if they tell you to simplify or put it in the simplest form. This means that you have to simplify. But if they don't ask you to simplify, you can leave it like this, okay? Yeah. Now, um, A total less than 4. A total less than 4. Yes, a total less than 4. This means we don't count the fours because they want what's less than 4. What's less than 4. So let's count the ones less than 4 here. Give me a second. Yes. The ones less than 4 are 1, 2, 3. Ah, good. We don't count this. So 1, 2, and 3. So the ones less than 4 are 3. So we don't count the fours because they didn't say at least 4 or 4 or less. They said less than 4. So we have 1, 2, 3. So it's going to be 3 over 36. 3 over 36. Yes. 3 over 36. And then the last one is a prime number. A prime number. Now, a prime number, first we have to count the prime numbers on the sample space. Prime numbers start with 2, so this is one of the prime numbers. And then we have the 3s, these are prime numbers. We have the 5s, 1, 2, 3, 4, 5. We have the 7s. Let's put a mark and then we're going to count them, okay? And we have the 11s as prime numbers. Now let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 prime numbers. So a prime number, 15 over 36. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Good. So 15 over 36. And then the last question, what is the most likely total? When we look at the sample space table or sample space diagram, we'll notice that the 7 is the most likely total. So the 7 is the most likely total. And this is how you answer a question like this. Now let's move on to the next question. Another question that uses the same idea about sample space and the sample space table is this question. A regular five-sided spinner is spun twice, and the scores are multiplied. So here, the scores are multiplied. As we said, always read the question. Copy and complete the table or the sample space table. So first, we're gonna fill the blanks or fill the gaps by multiplying the scores together. Here, let's use this. So first, 1 times 1, 2 times 1, 3 times 1, and then 4 times 1, which is 4, and 5 times 1, which is 5. Now we multiply this by 2. So 2 times 2, 2 times 1, 2 times 2, 3 times 2, which is very good, 6. So we're multiplying. Focus on the questions and what they need. 4 times 2 is 8, and 5 times 2 is 10. Now the next ones, 3 times 1 is 3, 3 times 2 is 6, and then 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. Next, we have 4. 4 times 1 is 4. 4 times 2, 8. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. And 4 times 5 is 20. And then the last one is 5. So 5 times 1 is 5. Times 2 is 10. Make sure that you check with me. Maybe I have mistakes. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. And this is how you fill the gaps by multiplying the scores together. As we always say, read the question, understand what's wanted from you, and then fill the gaps using the information that you have. Now we're going to use the table or the sample space table to answer these questions. Use them to calculate probability of scoring an odd number. First, let's count how many odd numbers. As we said, the total probabilities are what? Or the total possible outcomes is what? Very good. It's going to be 5 times 5. 5 times 5. So we have 25 possible outcomes. So we write it here so we don't forget it. 25 possible outcomes. This will help me in finding all the probabilities of these numbers. Now, first we need the probability of an odd number. So let's align on odd numbers. Odd numbers start with 1, and then 3, and then 5. Focus on odd numbers. All of these are even. This is odd, odd, odd. Even, 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 even. Odd, odd, odd. So how many odd numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 odd numbers, and the total is 25. So 9 over 25. So 9 over 25. Good. So that's the idea. First thing, odd numbers, which is 9. As a probability, I have to put it on the total possible outcomes, which is 25. Now, the probability of a number less than 9, a number less than 9. So a number less than 9, let's count them. It means we don't count the nines, only the numbers less than 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 numbers which are less than 9. Make sure that you don't count the 9 because they said less than 9. If they say at least 9, it means you have to count it. For example, at least 15, like this. But at least 15, you count 15 and above. So focus on this. Now, as we said, less than 9 is 14, and the total is 25, so 14 over 25. Now, a number of at least 15, at least 15. It means count 15 and above. So let's count them here. So we have this 1, 2, 3, 4, 5, 6. So we have 6 numbers in which of at least 15. So 6 numbers, it means 6 over 25, 6 over 25. And then the last one is a triangular number, a triangular number. We know what's the meaning of triangular numbers. Triangular numbers are numbers that makes a triangle, that makes a triangle. For example, let me show you how. I'll draw the shape for you so you know the idea. Triangular numbers, they make a triangle. For example, this is a triangle. I can use one circle to fit inside a triangle. I can use one circle like this, show you, to fit inside a triangle. So it's not that perfect. This means that 1 is a triangular number. 1 is a triangular number. And then let's move on. I'll use another triangle. Okay. I'll make another triangle, yes. So 1 is a triangular number. And then after 1, we will have 2 in the base and 1 on top. So 1, 2, 3, like this. I'm not that good at drawing, so you have to bear with me. So 1, 2, 3. So because 3 can fit inside a triangle, this means that 3 is a triangular number. And then it goes on like this. So the other one will be, very good, it's going to be 6. So 1, 3, 6. These are triangular numbers. So I'm going to do 6 here. Let me pause this for a second. Now, after writing all the triangular numbers here, now basically triangular numbers means the numbers that can fit inside a triangle that makes an equilateral triangle. And equilateral triangle means all the sides are the same. So 1, 1, 1. Here we have 2, 2, 2, and here 3, 3, 3, and here 4, 4, 4, and then we have 5, 5, 5, and it goes on 6, 6, 6. You can understand it that way, or you can understand it as a sequence. So basically, triangular numbers, they start with 1, and then you add 2 to it to get the next one. So 1 plus 2 is going to be 3. And then you add 3, you get 6. You add 4, you get 10. You add 5, you get 15. You add 6, you get 21. So basically, it's a sequence and it's a quadratic sequence. It's not an arithmetic sequence. It's a quadratic sequence, and this quadratic sequence starts with 1, and the second difference is 1 or plus 1. So every time we add a number to it to get the next triangular number. So we add 2, we add 3, we add 4, we add 5, and it goes on. Okay. Now I stopped here because this is the last triangular number inside this sample space table that I'm gonna use. Okay. So what's the probability of triangular numbers? Now I'm gonna check how many triangular numbers we have. So first we have this 1, and then we have the threes, and then we have the sixes. How many sixes? One, two. And then we have the tens. One, two. And we have the 15s. One, two. Now we count how many triangular numbers. One, two, three, 4, 5, 6, 7, 8, 9. So we have 9 triangular numbers. So the probability of triangular numbers is 9 over 25. And this is how you answer a question like this. So focus on the idea of sample space table and how to fill the gaps. Read the whole question to understand what they want you to do, and make sure that you understand all the terms that needed from you. Now let's move on to the next question. So sample space is done. Now let's do a question, yes, related to algebra like this one, which will be the last question here. Yeah, let's do this. Yeah, I think there's another one that's the same but with numbers. Yeah, not here. Okay, I thought there's another one. No. Okay, let's use this then. The algebra question. We don't have to answer this question. I just want to explain how to uh, get them. Okay. Okay, let's see. Hey? The table gives the probability of getting each of 1, 2, 3, and 4 on a biased four-sided spinner. These are the numbers or the possible outcomes, and this is the probability of each possible outcome. Now, in the probability section, we have a variable, which is x. Now, to find this variable, we have to use the information that we know about probabilities, that the sum of all probabilities is equal to 1. It's always equal to 1. This is very important. Sum of probabilities, of all probabilities, equals 1. This is very important. You have to understand this and know how to use it any question. So the sum of probabilities is always 1. This means when you add all of these together, you'll end up with 1. So I'm going to write them as an equation. 4x plus 3x plus 2x plus x equals 1. That's the first step you're going to do to solve or answer a question like this. And to find the missing numbers in the probabilities. So first I made an equation. Now I'm going to add them together. 4 plus 3, 7. 7 plus 2, 9. 9 plus 1 is 10. So this means 10x equals 1. Now I want to make x the subject. It means I'm going to take the 10 to the other side by dividing. So take it by dividing, and I'll get the value of x. So the 10 will come here by dividing. So x will equal 1 over 10. X will equal 1 over 10. And 1 over 10 equals what? Very good, 0 0.1. 0 0.1. You can write it 1 over 10 or 0 0.1, same idea. Now, this is the missing variable here in the x's. Now I can put each 0 0.1 inside its place and multiply it by the number next to it. So 4 times 0 0.1 will be, very good, 0 0.4. And then 3 times 0.1 is going to be 0.3. And this one is going to be 0.2 because 2 times 0.1 is 0.2. And this one's going to be 0.1. Now, when you add these, you'll get 1, as we said before, to check. If you want to check if the probabilities are added up to 1, you can add them together to check if you did the right steps. Now, after doing this, finding the probabilities, um, after finding all the probabilities, now after finding each probability alone, I can answer the questions that I have here. So, first question says, what's the probability of getting 2 or 4? Now, 2 or 4 means 2 or 4 separately. This means that you have to add the probabilities of 2 and 4 together. The probability of 2 is 0.3. The probability of 4 is 0.1. So we add them together. Let's take this here. Let's skip this. Okay. So we add this together, 0.3 and 0.1 is going to be 0.4. So let's write them here, 0.3 plus 0.1 equals 0.4. And this is the first question. Second one, what's the probability of getting a 1 or a 2 or a 3? So basically, we add them together. Same idea. Focus on this. The word or means you can add them together. Now, the word and means they have to happen at the same time. They have to happen at the same time. So the probability of getting a 2 or 4 is 0.4. Yes. Probability of getting 1 or 2 or 3, 1, which is 0.4, plus 2, 0.3, plus 3, 0.2 equals 0.9. So the probability of getting these is 0.9, and this is how you answer a question like this. Now, is it okay to write the probability as a fraction? Like 0.4 is going to be 2 over 5? Yes, no problem. Or you can write this 9 over 10, for example. Yeah, 9 over 10. Because probability can be fractions, can be decimals, can be percentages. I can write this 9 over 10, or I can write it 90%. 90% like this. No problem. But if they ask me, write it in a certain way, I have to follow this way. So I can write it in any way I want. Okay? As long as they didn't ask me to write it in a certain way. Because sometimes in the questions, they will tell me to write the probability as a fraction, or write the probability as a decimal, or write it as a percentage. But if they didn't ask, I can write the probability in any form I want. That's it for this question. I hope you get the idea. Make sure that you practice, make sure that you understand all the facts. This is one of the important facts in probabilities, that all probabilities add up to 1. Sometimes they will give you some of the probabilities and the others are missing. So you have to find them using this rule. And make sure that you understand all the questions about probability. That's it for this question. I hope you get the idea. Thank you very much for watching. See you next time.